Okay, what you got?
4.2 from our number system to the
Shit. 4.2 number 33? All right, book. Oh, okay.
I just didn't understand how the base 60.
Oh, okay, okay. So let's just talk about Babylonians in general. Babylonians. What's going on?
You're getting his ID, dude. I don't know why.
Is it dry? What base did Babylonians use?
60.
Base 60. Good so far? So what is that? What's the first place pretty much always going to be?
1.
Yes, pretty much always going to be 1 no matter what base you use. So it's 1, it's like 60 to the 0 power. And our system, so that's Babylonians. Let's look at our system. Ours, we have 1, 10 to the 0. What's our next place up? The what place? Tens. 10 to the first, right? So tens. The next place would be hundreds, 10 squared. The next place would be thousands, 10 cubed. So what's the next place for Babylonians? 60s. Like 60 to the first. The next place will be 60 squared. 3,600. And so forth. Let me stop there. This is good, because it's going to feed right into what we're going to do today anyway. So, specifically, if I had, for example, the number 917, how far up do I have to go? Do I have to go up to here?
No.
No. Are there any 3600s in 917? No. You guys with me? I don't need this to make this. It's too much. So I just need to start here. How many 60s are in 917?
11.
15?
Yeah, what's 15 times 60?
900?
Yeah, cool. So 15 60s. Is that cool so far? 15 times. And how do you do that? In your calculator, you put 917 divided by 60, and it tells you, what does it tell you if you do that? What's 917 divided by 60? 15 point, who cares? Are you with me?
Yeah.
Because 15 goes in. So 15 times 60 is 900. How much is left?
7.
So then this place needs 17.
Okay.
Now, real quick, if I write this down, how many places are there? There's 4 places there, right? For our number system, there's 4 places. But for the Babylonians, how do I write 15 for the Babylonians?
The little...
The little arrow. and
Pac-Man dude.
5.
I like it. All right. The minus sign would be kind of silly. All right, 5 is 10 minus 5. No, all right. 17. So you can do the same. You can do that and did I get that right? 4 7. Or you could do 20 minus, and it's about even either way, right? You could do 20 minus 3. Cool.
Yeah.
Yes. So if you won't need 3 places until you get a number that is more than 3,600. Then you'll need this. Then you'll have one of these in it. Right now I have 0 of those in it, so I don't need that place. I don't need any bigger place than this. How are we doing there? Is that right? Yes, ma'am.
What does it say next to the
It looks like it's the hours.
Oh, okay.
There's the Babylonians and our system. All right, so here, round tails of that. You guys do this for me. What would this look like in Babylonian? Try. Do it. Or draw a Babylonian. At least pretend like you're doing. I feel like Jim Bush. Clap. All right, good. You guys got that joke. It's good.
That
I
was
like
kind of
it.
sad, though.
It was
I
so
felt
sad. It was so sad. But it was so funny. This my brother was up here, he cried. So definitely need 3 places here, right? Somebody got their calculator. All right. Do me a favor. For the rest of you, I'm gonna get you to do something nifty. If you have a calculator, you might want to get it out. It's gonna be kind of nifty. Do 4111 divided by 3600. Even though I know you already did. Do it again. Sorry. Do it now. All right. So you know it's 1, but it's 1 point something, right? All right. Now watch. So subtract 1. Now multiply by 3600.
Hey, well, that's like
Wait, no, negative. All right, somebody went wrong.
511.
511. Yeah. Because what's 41 and 11 minus 3600? 5 frickin' 11. So it's interesting. If you obvious, I'm going to tell you about another mathematical way. If you divide 4111 by 3600, the remainder, if you multiply it back by this, it'll tell you the number that was remaining. Right? Because when you divide 4111 by 3600, you'll get 1 and something 3600ths. And that's the point blah, blah, blah. So if I multiply by 3600, that remainder, subtract 1, multiply by 3600, I'll see what the remainder was. Now, on the other hand, that's kind of like, well, whoop-de-doo, I can subtract, but it's kind of nifty anyway. I don't care. So I got 511 left. So let me make sure you guys are with me. So I don't have to do any of that weirdness I just did. 4111 divided by 3600 is 1 point something. This is 1. Subtract the 3600. I got 511 left to take care of. 60 goes into 511 how many times? 8. 8 times 60 is? 480. 31. And then, so this has got to be 31. Yeah. So then how do I write that? 1. 1. Straight. 8. We can do 10 minus 2. I like it. 10 minus 2. Is that cool? 10 minus 2 is what that means.
That's objectively more work, though.
What's that?
Just like the 8. It's objectively more work.
Let's see. 1, 2, 3, 4, 5, 6 symbols. 1, 2, 3, 4, 5, 6, 7, 8 symbols.
There's no 5.
Sorry, buddy. Yeah, exactly. We got to go back in time and say, listen, first off, 0.
And 5.
And then let's add some 5 in there. Yeah. What about 31? That would just be
30.
I like the 31. I like the way you guys answer. 30 and 1 is 30. That is groundbreaking. 3 little Pac-Man dudes and 1. 1. I like it. Okay. Cool. All right. How we feel about that? The more you understand Babylonians now, the easier the next section is going to be. Because the next section is going to be any damn base I want to do.
I feel like when I was doing it, I thought all the numbers were stuck together, but there's spaces.
Oh, yeah, exactly. Yeah.
Yeah.
All right, is that all right? I heard a sound.
I said yeah, I like this.
Oh, okay, thank you. All right. I didn't know what that sound was. So you're trying to get my attention?
Voice. Yeah, no.
I like that. I call your voice a sound. What was that sound? She was talking.
Isn't that what it is? Just voices, just
Totally is. Sounds we ascribe meaning to. All right. Anything else? Any other questions from homework? Okay, let's get into it. Here we go.
So is this just now 3-2 or 4-2?
That was 4-2. We're getting to the 4-3 today. Yeah. 4-2 is Babylonians and Mayans. If you do go to Chipotle to see on their wall, just go there. Don't eat there. I don't know how their food is nowadays. Okay. So let me ask you this here. Let's just get right into this kind of thing. What would base 7 look like? What would the places look like?
149.
Still going to start at 1, right? 7 to the 0 power. The next one's going to be 7. And then 49. 7 squared, right? And so forth. Then the next one will be 7 cubed. And you can just keep, whatever far you got to go, you just keep going that far. Just keep going one more if you need another one. How are we doing so far? So right now, before we get into any of the weirdness, we could just do this. This is easier than Babylonians, because Babylonians, number 1, they had different symbols than us. And number 2, they had base freaking 60. So now, the nice thing with section 4.3 is we are going to pull it back to be our symbols, not some other civilization symbols. We're going to use our symbols that we're used to. But now the base could be whatever the hell we feel like making it, or they feel like making it, or I feel like making it, right? So it could be base 7. So if I wanted to convert, let's start off with this. If it starts off in base 7, and the way that we denote something as in a different base is to say something like this, 512, and then put a little 7 down there. That means 512, it's in base 7 right now. So what does that mean? 5 whats?
49.
Good, beautiful. So when it's in their base, this is why it's easier to go from somebody else's base to our base, base 10, is because all the spots are filled in. They're not blank. There's a 5, a 1, and a 2. It's already in base 7, so I already know there's a 5, a 1, and a 2 there. I just got to put it back together. 5 49s plus 1 7 plus 2 1s equals 254. 45 and then, yes, cool, I like it. You guys with me? And if there's nothing written down there, obviously that must mean it's our base. We don't write nothing because we know that's our number there. 254 base 10. Don't put a little 10 there. How are we doing so far? Is that... So you see, that's why it's nice to go through 4.2 first, because Babylonians are a little freaky. They use different symbols. They use base 60. But now, this should be relatively easy. All right, let's try another one. So that's number 1. Let's try, what if I gave you this here? Make sure everybody's reading that right. What base is that in? All right, take a minute and convert that into base 10. If you dare. Real quick, anybody come in after I gave out this assignment? Let me know.
So is this all a segue into logs?
Logarithms?
Yeah.
Not really. I mean, this involves powers of things, so you could tie it into logarithms, but we're not going to talk about logarithms. Yeah.
Why is there one underneath the two?
Because it's in the ones place. I haven't filled in the other ones yet.
Oh.
What place is this one in?
The 3,
3s,
9,
9s,
27,
27s,
81.
81s. And now you just got to say 181 plus so forth, right?
Yeah.
Not a big deal. So what did you guys get? Anybody got that?
139.
Do it again.
139.
139?
140.
149?
Oh.
You never know. See, 81 plus 54 plus 9 plus 3 plus 2. 135, 144. Yeah, I get 149. Woohoo! Okay. All right, I like it. So this is math. I agree with you. It's not very difficult. It's easy math so far. Notice how I wrote this number, though. Why do you think I wrote? What's weird about this number? Is there anything weird about this number? It's very careful. Yeah, I say the same thing about this number, but this number is a little more in your face. The highest digit I used
It's 2.
is 2, because in base 3, nothing 3 or more don't exist, right? So let me remind you. In Babylonian, who remembers the biggest single digit number I could use, considering the places? What's the biggest single digit number I could do?
59.
59. Because to make 60, I would just need 1 and empty space and pray, right? Let me stop there. You guys understand? And base 10, what's the biggest single digit that we use?
9.
9. 1 less than the base. So in base 3, what's the biggest single digit I can use? 2. 3 doesn't exist as a digit. How do I write 3 in base 3?
1.
Change the places.
Almost. 1 in base 3 is 1. 3 in base 3 is 10. Because what place is this?
1.
This is the 1's place, and this is the...
10. 3.
In base 3 is the 3's place. Let me let you absorb that.
Oh.
Dude.
You can use them.
You guys semi with me here? So how would I write 11 in base 11?
1.
1 is 1.
Wait.
So what's base 11 look like? What place is this?
11.
The 1's place. What place is this?
11.
11's place. So how many 11's do I need for 11?
10.
And how many do I have left? How would you write pi in base? Oh yeah,
Like 5.
pi.
1.
10? Because I need 1 pi and 0 ones. And yes, base pi does exist. I'll let you go over it if you want to. Nobody's going to, but I will just throw it out. Base E exists, base pi exists, base all kinds of weird ass bases. Negative bases exist. We're not going to go there. We're going to use nice whole numbers. Okay, you guys with me? No. Yes? All right, we're starting to get into the weirdness now. So fundamentally, if I give you a number that's in a different base, that is an easy problem. Does everybody agree? I could do anything. I could even do base pi, but I won't. So just to make sure that's true, what is this? What's that in our base? How would you do it? What base is that? 16. Great. So what place? That's always
1.
because it's 16 to the 0. This is 16 to the first. This is
Whatever the hell 16.
whatever the hell 16 squared is.
That.
256. Good. So they are filled. They are filled in. What happened to me there? Right? 121, 2028 base 16. It's filled in. I know I got one of these plus 2. So let that be easy. Do you guys understand what I'm saying?
Yeah.
I can give you any base I want to. If I give you a number in a different base, it's easy. I don't care what base it is. It's easy. You guys kind of agree with me a little bit. I know this is a little new, but not really. It's old. So what do I get?
96.
Yeah, so it'd be 256 plus 32 plus 8, 40. That's 296. Kick ass. And there's no little number on it, so I know it's base 10. I don't have to write a little 10. This is our base. We don't have to tell ourselves what it is.
So you're saying 128 and 296 are the same?
Yeah, I love it. There's an idea. This is why the first section makes a big deal out of answering the question how many versus the digit or the symbol that I use to represent it. There's an idea of this many things. And if I use base 10, and we use base 10 just because we have 10 fingers. That's it. If we had 12 fingers, we would use base 12. And it only makes sense because that's the most natural way to count something, right? 3 rock. It's the most natural way to count something is right there, right? And their feet is the next thing, but then we got to do this.
Then you got that crazy trip with the 9s.
Oh yeah, exactly. You got all kinds of weird shit. Base 12 would certainly make that different. There would be other tricks. But anyway, so yes, 296 base 10 represents the same amount of something as 128 base 16. They represent the same amount. Okay, I like the question. All right. So, what about going the other way? What I mean is starting in base 10 and going to some other base. So let's see. Okay. So if I wanted to convert, what you got, Jeff? Doesn't matter. 303 to base, let's say 8. So what I always tell people is you go until you're one place too many. That makes sure that you went far enough. What do I mean by that? So what's the first place? 1. I need more than that. Okay. What's the next place for base 8? 8. All right. I don't know if I need more than that. If I do 8 into 303, I'll get a number, won't I? But it'll be too big. Right? What is 303 divided by 8? Who is it? 32 something, right? Can I put a 3 and a 2 in one place? No. Okay, shit. So if you don't go far enough, you're going to get too big of a number here for base 8. I don't know if you guys see what I mean. So what's the next place?
64.
Do I know yet? Well, not. What's the next place?
Too large.
Yeah, 512. But you do that just to make sure. Now you know that this is far enough because the next one's too big. Do you guys see the reason for that? You got to trust me on this because people will give me that 32 as an answer. I'm like, no, that doesn't make any sense. I can only put one digit in each place. We're not doing the Babylonian thing where they just cram every place with all kinds of freaking symbols. No, we can only put one digit in one place. I like it. Okay, so that's a little suggestion. You don't have to, but I would highly recommend it. So now how do I start to do this? This is just like Babylonians now, except I don't have to convert to Pac-Man and sticks.
64 is going
Yeah, 64 goes into 303
4.
4 times. 4 times 64 is 256. So 8 goes into 47 5 times. So 303 in base 10 equals 457 in base 8. I really love this because on the one hand, this is really easy little computational playing around, but if you really stop to think, if we had 8 fingers, and again, we don't want to lose our thumbs, if we had 8 fingers, we would use this, we wouldn't put the 8 because we know it's, we wouldn't even have a symbol for 8. What would 8 look like? 0. 1, 0. It would look like 10. Right, we would use that number when we mean this many things. We just would. Why do we use this number right now? Because we have a base of 10. Because we have 10 fingers. We're going to keep doing that. So if we would have evolved differently, if we would have had a different number of fingers. Lizard people, right? We don't have to go that far, but sure. Right? Some of us are. We're supposed to keep it on the down. All right, so they caught us in some of that Obama security guard, but can't always hide every day. Are you guys get a feel for it? Don't worry about the lizard people. I always think about Land of the Lost. Oh, it scared the hell out of me. Let's look at. All right. So here, you guys try this. Try to convert. What you got, John? 1402 to base 9.
How do we know definitively that that's why we have base 10?
Well, to be completely honest, we don't know definitively, but it's a really damn good guess.
Yeah.
Right? I mean, it's just a natural way to count. But to be honest, there's no obviously there's no record of it. It's way before there were any written records when people first started figuring out ways to count things. And then it makes sense that once they figured out how to count things, it would carry through So you see base 10 in all these disparate civilizations stuff, right? Like the Egyptians, they don't have a base, but they basically use 10.
All
Chinese
isolated
10.
and simultaneous.
Yeah, without influence from each other. Exactly. Yeah. So
So where was the record of the first base 10 being used?
actually, wait. I used to know that.
Come on, get your trivial facts down, Dave.
Oh well, too bad for me. I would lose that Jeopardy. You got Google?
Yeah.
All right then. Good. And like people will be texting, I'm Googling this, Jeff. It's very interesting what you're saying. Oh.
I still can never find why the Romans only used 2 subsequent.
Exactly. Yeah. If you do, let me know. All right, guys, help me out. How are you guys working this? What's the places here?
81.
The next one would be like 6,300 or something or other. So it's going to be 6,000. That's too many. Right? You do 729 times 9 to figure out the next one. Is everybody cool with how to figure out the places? You just keep multiplying by the base number. That's how we get the base 10. I like it. So then 729 goes into 1402 once. 1402 minus 729 is
672.
673. 81 goes into 673.
8.
What? 8. So that's 648.
25.
9 goes into 25. Twice.
18.
So 1402 is 1827 base 9. All right, cool. How are you feeling about it? Notice something. The number I started with, the digits I used to start with, when they go to a lower base, what happens to the digits? They get bigger. That kind of makes sense because every place is smaller. It's going to take more of each to cover the same size number. I don't know if that sentence made sense to you. So if I went to base 12, if I took 303 to base 12, it would come out to be less than 303 at the end. Let's talk about base 12. What's weird about base 12? Base 9, what's the largest single digit I can use? 8. Base 12, what's the largest single digit I can use? Say it. 11. Now that's weird. We don't even want to say that. You got to stay with me because this is where things get really weird. Anything yet, Garrett? No?
This is from India.
From India?
Yeah, so the system comes to us primarily from India.
Oh, that's too specific, I think, of a system. Anyway, okay. Come back to me here now. Base 12. So I need to be able to use 0, 1, 2, 9, 10, and 11. They have to be single digits. And let me show you, before we even come up with them, let me show you why. All right, let me try. Let's do, what you got, Jeff? Let's do 155. Let's convert that to base 12. So what's base 12 look like? 1, 12,
144.
I like it. All right, and the next one would obviously be 1200 something. That's too much. Yes, ma'am.
So the 10 and the 11 have to be like a weird symbol that doesn't.
Well, we'll see. It's not going to be a weird symbol. We're actually going to choose a very normal symbol. It's just been chosen already. If any of you guys have ever heard of hexadecimal base 16, if you've ever worked directly with, if I say HTML, are you guys understanding what that is? Right, it's the language, hypertext markup languages, what we use to make websites. Nowadays, there's these stupid Microsoft front page crap that you type in and it makes this disgusting code in the background. You guys don't even care, but I'm a coder at heart, and we like nice, concise, compact little programs. But HTML assigns a hexadecimal number, a base 16 number, to every color, for example. right? So you could represent a color using these symbols that we're going to talk about here in a minute. So if you've ever seen this code, I have to see if I can't find it on the internet again. You just say view source on a web page. Have you ever done any of this? Go to a web page, say view source. If you look through and you'll see in a minute. I'll show you what it would look like. First off, I want to show you why they exist. So 144 into 155 goes, that's crazy. With how many left? 11. So how many 12s do I need? None. So how many 1s do I need? Freaking 11. Now if I write this 1011, well how many places are there? 4. So what places would be 1, 12, 144, and then whatever 144 times 12 is? Is that what I mean? Is that going to work out to be 155? No. So do you guys understand? I need one place. But in one place I can only put one digit. So what we use, what's been chosen way back when, is we use the letter A, B. A means 10, B means 11. So base 16, guess what we do? 12 would be, oh that's crazy. 13 would be D, 14's E, 15's F. Because in base 16 you have to be able to go up to 15. So all this means, all that letter B means is when I go to write this, I would write it as 1, 0, B. Why do we need a B? Because I need something that represents 11 that's a single place. So if we had base 12, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then whatever other thing we would have created for to mean 10, a single number, and then whatever we would have made to mean 11, a single thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, Umkla and Ik, or something, I don't know. That's exactly what we would have used. Umkla and Ik. It only makes sense. So 10B base